Okay, so in this first lesson, we're going to do a quick review to allow you to have a good performance on your diagnostic test. So let's start with this problem. Number one, simplify the given algebraic expression. This expression contains parentheses, so we're gonna have to use distribution to cancel the parentheses. So let's distribute 6 over to all the terms inside and the -1 here over all the terms inside. The -1 will change the sign of everything inside. So that's 18y minus 18 minus 6y minus 5. And then we can combine like terms. Plus 18y minus 6y is 12y. Negative 18 minus 5, same sign, we add, so that's negative 23. So that is the simplified expression of the given expression. Number two, simplify the given exponential expression. So one of the property you need to be reminded of to solve this problem is if I have an expression a with exponent p raised to the exponent n, the end result is a exponent p times n, or n times p, n times p. So multiplication is commutative, so it's not going to be a problem to have n before p or p before n. So a exponent pn or np is going to be a exponent p exponent n is going to be a exponent n times p or p times n. Basically here we're gonna have the x is the a in the formula, and -6 is the p, and 7 is the n. Multiply them, it's negative 42. And since the exponent is negative, it says that we don't want to keep any negative exponent. So your end result, you always want to have it with a positive exponent. So if you have another property you need to know about, if you have a exponent negative n, it's equivalent to 1 over a to the n power. So it's like you remove the negative sign in the exponent and put a 1 as a fraction, 1 as a numerator of the fraction, and then a exponent, the positive number. So that's going to give me 1 over x exponent 42. So we can convert the expression from the negative exponent to a positive exponent. So we can have the result here that is x exponent -6 raised to the 7th power is equivalent to 1 over x to the 42 power. To the 42nd power. Okay, so that's the answer for number 2. Number 3, we were going to apply the same property we used in number 3. We're going to use the same property we used in number 2, but we need to make sure we simplify the expression in the inside of the parentheses first. So properties we need to know is that if you have a exponent n over a exponent p, a exponent n over a exponent p is a exponent n minus p. So that means if we have an exponent, the same base, and one expression is on top, one expression is on the bottom with different exponent, we can just keep one base and subtract the exponent from the top and the bottom. But if you have a exponent n times a exponent p, it is equivalent to, now you add the power n plus p. Now you need to remember, when you multiply the powers, you need to have power, exponent power, like an expression with a power, then another power that is on top of them. But if you have the same base multiply, you add the power. If you have the same base divide, you subtract the power. Then we're gonna use all three properties in this problem here. So let's see, we keep the fraction here. So let's start by dividing the coefficient. So -6 divided by 2 is -3. A exponent 2, A exponent -6, A exponent 6, A exponent 3, A exponent 6. So one thing you need to be reminded of is that the result of the subtraction, in order to keep it as a positive number, you want to keep the result of, after you apply this property, after you apply it, the result of this exponent subtraction will be wherever the biggest exponent is between n and p. So n minus p will give you a result. If you want to keep it positive, it should go wherever the highest exponent goes. So A exponent 2, A exponent 6, 6 is bigger than 2, n minus p, you don't have to care about which one is n, which one is p. If you subtract them, the result will go where the highest exponent is. So result here is 4, A exponent 4. A exponent 4 goes in denominator because 6 is greater than 2. Same thing will happen for B. B exponent 4, B exponent -2. So result will go on top. But you're going to have 4 minus -2. 4 minus -2 gives you 4 plus 2 minus negative. Minus negative is plus. So 4 minus -2 is 4 plus 2, which is 6. So that's B exponent 6, and keep the exponent 3. Now the exponent 3 will be not only we will apply this property here now. This property here we will apply, but we want to make sure that this exponent outside is also the exponent of our coefficient in this expression. So the coefficient we have is -3. So first we're gonna start with -3 exponent 3. -3 exponent 3 is -3 times -3, positive 9, times another third -3 will be -27. So -27. B exponent 3 times 6 is 18 over A exponent 4 times 3 is 12. So final answer for this problem is -27, B exponent 18, and A exponent 12. So that's it for number 3. Now let's see number 4. Number 4, we have a radical expression. They say to simplify. Now, whenever you're simplifying a radical expression, you need to make sure that you look for 3 things. The first one is whether the expression you're simplifying the radical is a perfect square or perfect cube or whatever the index of the radical is. When I say index, your radical is given in this form. But when the index is greater than 2, it's empty when you have an index that is 2. But whenever the index becomes greater than 2, you will see the index right here. So that's nth root of something that we call a, for example. And whenever you see the expression a under the radical, and the index indicates how many times something multiplied to get a, or what's the power of something that will give you a. Now, whenever you want to solve this expression, simplify or solve the radical, you need to look to see whether this expression is a perfect cube or perfect nth exponent of the of something that gives you the a, and then that will make it easy for you to solve it by just solving the square root. You can even use your calculator to solve it. But that's the first one. The second option is that you can have something that is not a perfect power of the index, but can be broken down as a product of a perfect factor of the index and a number that is not a perfect factor of the index. And the third situation is when you have something that is not a perfect factor, perfect power of the index, not a product of one perfect factor and one number that is not a perfect factor. So this case is going to be not being able to simplify. So you won't be able to simplify this case. That's the third case. But this situation, we know that 150 is not a perfect square because the index is 2. The radical doesn't have the index written, so that means the radical it's the square root. Now we need to see first that 150, there's no number to multiply itself to give 150, but that's not enough. You need to make sure that 150 doesn't have a factor that is a perfect square and that will be able to be simplified, to be broken down. And if not, then you would say that square root of 150 is not simplifiable. But in this case, we will see, because I know 25 goes into 150, and it goes 25 is a perfect square because 5 times 5 is 25. So 25 being a perfect square, and it's a factor of 150. Now we need to figure out what multiplies 25 to get 150. That's going to be 6. And then now we can separate the radical. That's 25 times 6. Square root of 25 times square root of 6. We know what the square root of 25 is. That's 5. So my final answer is 5 on the outside, and then the square root of 6, because 6 is not a perfect square. Answer for number 4. Number 5. Find the degree of the polynomial. Degree of a polynomial is the exponent of the leading term, the exponent of the variable in the leading term. But it's that whenever you see that you have one variable. So the variable here in this expression is x, but sometimes you can have an expression that has multiple variables. So the multiple variables will be treated differently. So if I have x to the 5th, y to the 3rd, so we have two variables. The degree of this term is going to be the sum of the exponents. It doesn't matter which variable, you need to add the exponent of all variables, and that's going to be the degree of it. But if the expression includes only one variable, the degree of the expression will be the exponent of the variable in the leading term, and the leading term is the term with the highest exponent. What's the term of the highest exponent here? So we can look. Exponent 2, exponent 4, second term. Third term, exponent 1 because the power is not seen. When the power is not seen, the exponent is 1. Exponent 3. When you don't see the variable for the constant term, that means the variable had the exponent 0. So, which one is the largest? The largest exponent is 4. So, 9x to the 4th is the leading term. The exponent of the variable in the leading term is the degree of the polynomial. So, degree equals 4. That was number 5. Number 6, perform the indicated operation. So we need to add this polynomial with this one. All we do is combining like terms. We need to combine like terms. When our two terms are like, when they have the same exact variables or variable and the same exact exponent. Two conditions for two terms to be like. Same variables, same exponent. So we can see which one are like in this problem. This one will be like with this one. Now to combine, since we have the add addition sign, we just add the coefficient and keep the variable. Variable is going to be x to the 3rd, but negative 4 plus 7 is 3. So 3x to the 3rd. Now we're done with the first term. Now we're going to work with the second term. Second term, 10 plus 10x to the 3rd, to the 2nd, and plus 2x to the 2nd. 10 plus 2 is 12, x to the 2nd. Next term, like, is negative 10x, negative 6x. They have the same sign. We combine, we add actually, and then keep the sign negative. So negative 10 plus 6 is 16 and then x. And last term is constant term. We have plus 6 plus negative 6. It's like 6 take away 6, 0. So final answer for this is 3x to the 3rd plus 12x squared minus 16x is the result of the sum. What about number 7? Number 7, we have the product of two binomial. Two binomial, you need to use FOIL. FOIL. The first terms, first, outer, inner, and last. So multiply x times x, because these are the two first terms. X and x give me x squared. Multiply the outer terms, so x and 3, that's plus 3x. Multiply now the inner terms, negative 15 and x, that's negative 15x. And then negative 15 times 3 is negative 45. Then now, combine like terms. These two terms are like, we can combine them. So final answer is x squared minus 12x minus 45 is the answer for number 7. So now what about number 8? Number 8 is similar to number 7. They condensed the product whenever it's the same factor. So you have, if the two factors are the same, they condense it with a power, which means if I have a power 2, that means the expression that support the power multiplies itself 2 times. If we don't have, in this case, for example, 6x squared minus 7 exponent 2 means that 6x squared minus 7 multiplies itself. So 6x squared minus 7. And then we apply the same principle that we applied in number 7, which is FOIL. So that's going to be 6x squared times 6x squared, that's 36x to the 4th. 6x squared times negative 7 is negative 42x to x squared. Negative 7 times negative 7 times positive 6x squared is negative 42x squared. And negative 7 times negative 7 is positive 49. And then we can combine like terms to get the final answer. 36x to the 4th, negative 42 minus 42, that's negative 84 x squared, and then that's plus 49 to finish the simplification. And the answer for number 8 is 36x to the 4th minus 84x squared plus 49. You need to combine like terms first. Now let's see number 9. Number 9 is to factor by grouping. To factor by grouping, the essential part is that you need to have 4 terms. 4 terms, group them in two groups of 2 terms, and then find the GCF of each group, factor it out. Then you're going to have a binomial common factor that you refactor, and then that's going to be your final step for the factoring by grouping. So let's see with me. 4 terms, we group the first group, the first 2 terms. We make a group with the first 2 terms. I'm going to make another group with the second 2 terms. I have 2 groups. The GCF of the first group is x squared. So that's x squared pulled out. And then what do we multiply by x squared to get x cubed? That's x. What do we multiply by x squared to get negative 3x squared? So that's negative 3. Now, what's the GCF of the second group? They don't share anything except for 1. So the GCF is plus 1. And then it's going to be the same, x minus 3. X minus 3 become the new GCF of your expression. Can pull it out, x minus 3, and open a new parenthesis, a new pair of parentheses in which you're going to place the remaining factors on the outside of each x minus 3. So the first one was x plus 3, and the second one was plus 1. So that finishes your factoring by grouping, your factor by grouping process. So that's your answer. That's your answer for number 9. In number 10, we're going to apply the same principle that we use in number 9, but it's 3 terms. Remember what I said? I said that you cannot perform factor by grouping when you don't have 4 terms. So it's your job to get 4 terms. How do we get 4 terms out of 3 terms? Look at me. Watch me doing this. First, you want to multiply the coefficient of x squared and the constant. That gives me negative 14. Negative 14, you break it down into 2 factors that the sum is negative 13. What are they? They are positive 1 and negative 14. We multiply 1 and negative 14, it's negative 14. We add 1 and negative 14, result is negative 13. So basically you need to check your factors. How? The product is the number resulted from multiplying constant and coefficient of x squared. And then when you add these two factors that you get from negative 14, they should give you the coefficient of x in this problem. That's when you know your factors are the right ones. Now, how do you use them to get the four terms? You use them since the sum of these terms, these factors gave you negative 13. I will remove the negative 13 in my problem by writing 1x minus 14x. So that will be my four terms because I already had the two terms in the beginning and the end. Now negative 13 is broken down into two other terms that gives me the four terms that I wanted, so I can perform the factor by grouping. My new problem becomes now 7x squared that I don't change. The negative 13 will change into 1x, so plus x, minus 14x, which is still negative 13, but I break it down in a way for me to get the right four terms that will allow me to move on with my grouping factor. Now we can group just like we did earlier, first group, second group. GCF of the first group is x. When I pull x out, it gives me 7x plus 1. GCF of the second group is negative 2. When I pull negative 2 out, it's going to be positive 7x plus 1. Now I have the binomial 7x plus 1 that is my new GCF that I can pull out again, 7x plus 1, and open another pair of parentheses in which I'm going to put x first and negative 2 next. That concludes the factoring of this expression 7x squared minus 13x minus 2. So my answer here is 7x plus 1 factor x minus 2. So that is my answer. Okay, let's move on to number 11. Number 11, since they have two terms, we need to look for GCF first and then apply whether we can have a special product. So first, let's find the GCF. The GCF is 2x. So when we pull 2x out, it's going to be x squared minus 9. 9 is 3 squared. So we can say that we have a difference of squares, x squared minus 3 squared. So whenever you have a difference of squares, the formula you use, a squared minus b squared equals, you're going to use the formula a squared minus b squared. That is a minus b times a plus b. So a formula is a squared minus b squared equals a minus b factor a plus b. So that's going to finish my factoring process. 2x stays on the outside, and then x minus 3, because 9 is 3 squared, and x plus 3. So that ends the process. We have that 2x cubed minus 18x equals 2x factor x minus 3 factor x plus 3. Okay, number 12. Number 12, we need to find the excluded values. The excluded values, because you have a rational expression, denominator cannot be 0. So we're going to solve x squared minus plus 9x plus 8 not equal 0. Two factors of 8 that add up to 9, because the 1, if you take 1, two factors of 8, that's 1, so 1 times 8 is 8. Two factors of 8 that add up to 9 is 1 and 9, so that's going to be x squared plus 1x. Oh, that's 1 times 8, sorry. Plus 8x plus 8 not equal 0. And then we're going to factor this expression nicely. So that's x, if we group these two, factor x plus 1 and plus 8, factor x plus 1 not equal 0. And then we're going to refactor this expression up here. So that's x plus 1 factor x plus 8 not equal 0. So that's x plus 1 not equal 0 and x plus 8 not equal 0. So we have the values, the excluded values for the existence of this expression are x is 8 and 1, negative 8 and negative 1. So x not equal negative 1 when we solve this one. And x not equal negative 8. So these are the two excluded values. Now let's go number 13. Number 13, we need to solve and check. I'm going to solve it and I'm going to let you check it on your own. So let's solve it. First, let's distribute 4 inside and 3 inside. So that is 4x minus 12 plus 16 plus 16 equals 3x plus 12. Combine like terms on each side. 4x plus 4 equals 3x plus 12. If we subtract 3x on both sides, that's x. And we subtract 4 on both sides, that equals 8. So x equals 8 is your solution. You can check it to verify the answer. Number 14. In number 14, we need to find the LCD and multiply both sides by the LCD. What's the LCD? LCD is the least common denominator. The least common denominator is going to be that one number in which all the factors are, all the denominators are, for which all the denominators are a factor. So when you look at 2, 10, and 5, 2 10 and 5, which of these numbers that all the other ones, including itself, is a factor? 10. 10 is a factor of itself because 10 goes into 10 once. 2 is a factor of 10 because 2 goes into 10 5 times. 5 is a factor of 10 because 5 goes into 10 2 times. So that makes 10 the least common denominator. So 10 being the least common denominator, now we can multiply everything by 10. Multiplying everything by 10 would mean that we need to first divide 10 by each denominator and multiply the result by the numerator of each fraction. So 10 divided by 2 is 5. 5 times 5 times 5 is 25, so 25x for the first fraction. The second fraction, denominator is 1, so 10 divided by 1 is 10. 10 times negative x is negative 10x. 10 divided by 10 is 1. 1 times x is 1x, so just x. And then 10 divided by 5 is 2. 2 times negative 28 is negative 56. So combine that terms, that's going to be 15x equals x minus 56. Subtract x on both sides, so 14x equals negative 56. Divide both sides by 14. Divide both sides by 14. So we get x equals negative 4. Now number 15. The following equation has denominator that contain variables. Find for this equation, A, write the value or values of the variable that make the denominator 0. These are the restrictions on the variable. B, keeping the restriction in mind, solve the equation. Now, if you remember in number 14, we did have denominator, but we did not have variable in denominator. So now when you have variables in denominator, the first thing you want to do is you want to make sure that the denominators, if there is a way for you to factor either the GCF or to factor completely each denominator. So that's why my first step is going to be see if we can factor 7 out for the first denominator. So that's going to be 9 over 7 factor x plus 5. And the rest remains the same. 5 over x plus 5 minus 2 over 7. Now, when I look, I see all my factors in denominator are 7, x plus 5. X plus 5, 7. So since it's only 7 and x plus 5 in denominator, my next move is to find the LCD, just like I did in number 14. So the LCD should be an expression that includes all the factors that I can find in denominator, which are 7 and x plus 5. So LCD is 7 factor x plus 5. It should include all the factors that I can see in denominator. I'm not talking about terms, I said factors. Now, in order to find the restrictions that they wanted me to find, the restrictions in the variables, we need to make sure that the LCD is never equal 0, because you know that if you have a fraction, the bottom, the denominator, cannot be 0. So you need to set the condition that the least common denominator should not be 0, which is 7 factor x plus 5 should not be 0. And then now you go ahead and solve, isolate x in this inequality. So we divide by 7. So that's x plus 5 not equal 0, and then subtract 5 on both sides, x not equal -5. So the restriction on the variable x is that x cannot be -5. Now, in order to solve, all we need to do is we're not going to forget that this is 7 factor x plus 5. Now, if we multiply both sides of this equation by the LCD, which is 7 factor x plus 5, we can cancel the denominator for each fraction. How we do that? So 7 cancel 7, x plus 5 cancel x plus 5. In the first side, I'm left with 9 equal. In the second side, what we will cancel would be just x plus 5. X plus 5 cancel. So I'm left with 7 times 5, which is 35. In the last fraction, what I'm going to cancel would be 7. 7 is gone here. And I'm left with -2 that multiplies x plus 5. And then now, no more denominator. I'm going to distribute -2 to have 9 equals 35 minus 2x minus 10. Combine like terms. 9 equals 35 minus 10 is 25 minus 2x. Subtract 25 on both sides. So that is going to be 9 minus 25, -16 equals -2x. Divide both sides by -2. So 8 equals x. So since the restricted value was -5, x equals 8 can be my solution. Number 16 is pretty similar to number 13. So first thing, we will distribute 5, and that gives me 5x plus 20 equals 6 plus 5x. We will subtract 5x on both sides. That cancels the variable. The variable is gone. I'm left with 20 equals 6, which is not a true statement. That's false. And for a false statement, we will have an equation that has no solution. If it was a true statement, then you would say all real numbers solution. In this case, it's no solution. Number 17. For number 17, we're going to use this coordinate system to graph. What they ask me, they say given the slope of the and the y-intercept of the line whose equation is this, they say graph the linear equation. We have the opportunity to have this line in slope-intercept form. Slope-intercept form. Because it's given as f of x, or it can be also y, equals a mx mx plus b, where m is the slope of the line, m is the number that is the coefficient of x, not including x, and b is the y-intercept, which means the value at which the line will touch the y-axis. So in this case, m equals -2/5, and then b is 1. Now, since we have slope and y-intercept, we can go ahead and replace them in the coordinate system. So b is 1, so I'm looking for 1 on the y-axis. 1. And then m, the slope, is -2/5, which means down 2. We need to say, from the point 1, from the point where the graph touches the y-axis, we go down down 2. From y-intercept, go down 2, and then after you go down 2, you're going to go to the right, since 5 is positive, then to the right 5. So let's do that. Down 2, and then right 5, down 2, right 5, so now we can draw a line and then extend both ways. So it goes indefinitely. So that is the line f of x equals -2/5 x plus 1. In number 18, they give me the line 5x plus y minus 4 equals 0. It is, they say, write it in slope-intercept form. Whenever you want to write in slope-intercept form, you need to solve the given equation for y. Means that we want y to be on one side by itself and everything else moved to the other side. So my equation A, they want me to find the slope-intercept. So my initial equation is 5x plus y minus 4 equals 0. I'm solving for y. Subtract 5x, add 4 on both sides. Subtract 5x, add 4 on both sides. So y stays on this side, and then everything else, -5x plus 4 on the other side. And it says, give the slope and the y-intercept of this equation. So remember here, we said when the equation is in slope-intercept form, the coefficient of x is the slope, and the value, independent value, is the y-intercept, which means where the line touches the y-axis. So the slope, which is m, equals -5. Sometimes you can even say -5/1 to determine how much you go down and how much you go left or right, or how much you go down or up and how much you go left or right. The bottom value is how much you go left, right, sideways, and the top value is how much you go up and or down, depends on whether it's positive up, negative down, the bottom number. If it's positive, you go right, and if it's negative, you go left. Now, the concern is sometimes I have students asking me if the negative sign is right in front of the fraction. Well, if the negative sign is in front of the fraction, you decide wherever you want it to be. You can decide for it to be on top, or you can decide for it to be in denominator. The thing that you cannot do is that you cannot decide for it to be both on top in numerator and denominator. You need to decide for it to be one of them, either numerator, so you go up or down, depends on what sign, if it's negative, or you can decide for it to be in denominator, one of them, not both. So for this one, it's negative 5 over 1. And the y-intercept is b equals, in this case, positive 4. So, and lastly, it says use the slope and the y-intercept to graph the linear function. So for you to graph it, all you're gonna do is to make sure you plot your y-intercept first. The y-intercept is 4. And then from 4, you go down 5 because it's negative 5. So down 5. Down 5, and then to the right just once. So that's that. So from 2 points, I can connect and draw the line. Of course, it goes indefinitely both ways. So that's the line. That's the line. 5x plus y minus 4. 5x plus y minus 4 equals 0. And that was number 18. Now number 19, they say, so I have the height of a football kicked, a football that is kicked vertically upward from a height that is 6 feet initially, and then the speed, the rate of the movement speed is 45 feet, and the formula is h, that's given to me, equals 6 plus 45t minus 16t squared. This equation describes the ball's height above the ground. H is the height in feet. T is the number of seconds in the air or after being kicked. Now they say use the formula, this formula, to find the height of the ball after 2 seconds. Well, what they want me to find now is, since h is in function of the time, t, they want me to find h of 2. That means the height of the ball after 2 seconds. All we need to do is to plug in, substitute t equals 2 into this formula. So the height is going to be 6 plus 45 times 2 minus 16 times 2 squared. You need to remember PEMDAS. You need to do this exponent first. So that's 6 plus, before you add, but you can do this one separately, plus 90 minus 16 times 4. You cannot do 16 times 2 then square it. You can't do that. You should take the square and then multiply 16 and 4. So that 6 plus 90 minus 64, and the height after 2 seconds, is, so that's 6 plus 90 minus 64. That's 32 feet. So that pretty much concludes the review to allow you to have a good performance on your diagnostic test. Your diagnostic test is due by the end of week 1 for this class.